Hello, my name is Plamena Vaneva, and I am an ethical hacker and security expert at the global architecture team at Experian. I have worked in the security domain for more than 10 years now. I have started as Java developer with design, implementation, and integration of security controls, but several years ago, I started exploring network and software offensive tools and techniques. Now, I am an ethical hacker as a job, and also vulnerability management as a whole has become a great part of it. Having both the defensive and offensive perspective has helped me a lot in trying to define and sometimes implement on top of the emerging DevSecOps practices. In the next hour, I will be sharing some practical steps into transforming to the DevSecOps approach for purposes of continuous delivery and continuous integration in the cloud. First, I will introduce a simple business case, which we will approach in the old way, and I will try to get insight how to adapt it to the DevSecOps process by the end of the presentation. So there is a standard model for release of enterprise software, let's say once or twice a year, with a service pack or hotfix against one in several months or so. Let's imagine that a new release is delivered by the software organization, and now it starts to be deployed for different customers. Before deployment to production, security checklist is filled, and also a manual penetration test is executed to validate proper security controls and to look for vulnerabilities. The results are given back to development and operation teams depending on the findings. So, for example, weak SSL and other misconfiguration at the server level will be given back to the operations team. But cross-site scripting at the application level will go to development team for service pack. So operations will get their configuration adjusted, and retest will be done to validate that all security issues have been resolved after the development has applied their patch on the software also. Usually, this process will take several weeks in the optimistic case because there are different teams involved in the process. Now let's say that we have two projects, two deployments following the same process, and we have two project managers receiving the manual security test reports. In this situation, we can have the following. Penetration tests are conducted by the same security team. Whether this is an external vendor or an internal red team, this doesn't matter because the methodology will be the same. Second, the penetration tests are executed against the same core software. The configuration of the software is following similar patterns because there are similar deployment patterns in the operations team. Yet the security reports will show different vulnerabilities sometimes. And maybe the project manager doesn't know about each other, but because all the flows at the application level will go to the same development team, it will be a bit strange because these tests are on the same system, right? So we will have some questions asked to the security team. One of these is a very good one. Which report is the right one? Right, we have the same system. And the most important one is, can such issues be resolved before the release? We're going back to this use case later, but before getting to actionable steps on how to make the security testing process better and faster, which is the reason DevSecOps has emerged as a concept, I want to ensure that everyone here understands the basics. So I will talk briefly on the DevSecOps approach and the OWASP software assurance maturity model. What is the connection between them and their importance for continuous delivery in the cloud? Then I will talk on the different types of security testing and tools and how this can be enhanced from DevSecOps perspective. At this point, we are going back to the use case, and I will show you an effective way to utilize the offensive approach and automation. Let's start with the DevOps and DevSecOps approaches, and they're important when developing for the cloud. First, why we want to bother with the cloud. The International Data Corporation, in their latest reports, know that worldwide spending on cloud infrastructure and services for this year will be about $160 billion, which is an increase of 23% over the last year. And software as a service, in fact, is the business which is growing rapidly here. And every company in software development is required to provide cloud-based solutions and services if they want to exist in the long term and if they want to have this profit. Moving to the cloud for the business incorporates speed of service delivery, flexibility, and scalability. And faster releases mean new functionality and bug fixes will reach customers faster, which would enable organizations to compete more effectively in the market. The question is how to build and deliver software faster. And this is the driver behind the DevOps approach in the first place. The DevOps model on its own means that you have development and operation teams, which usually different teams in an organization, using seamless approach and integrating on continuous monitoring and continuous automation during all the phases of software construction. This means creation, testing, deployment of the software, and even configuration and infrastructure management. Speed to response to customers' needs make DevSecOps approach adoption to increase very fast in the last years. The problem here is that the security teams have been left out of the DevOps discussion, operating at their own pace, and thus slowing down the DevOps process in the end. Because imagine we have the same approach with the use case several minutes ago. We will have a very optimized DevOps approach where you have the release in a week or two, but you want to have the security sign-off. So what is the deployment pattern? You have a penetration test, which will be, by the way, executed at least for 2 or 3 weeks again, then going back to development team, another release, another retest, and the actual deployment time will continue to be very big. DevSecOps approach implies that information security can become part of the DevOps process from the very beginning, and security controls are integrated to achieve automation with other relevant technologies. So in its core, DevSecOps automates security within the DevOps workflow to deliver speed and control. And adding more automation from the start reduces the chance of coding misconfiguration and other mistakes, which can lead to downtime or attacks. DevSecOps assumes that everyone is responsible for security and has led to creations of tools and techniques that are aimed at improved security at different stages of the DevOps chain. So as you can see here, security is part of the whole chain. The way to integrate security in the OWASP tool chain is given in the Software Assurance Maturity Model Framework, or SAM. It defines how a strategy for software security control software security as a whole could be implemented. At the highest level, SAM defines 4 business functions, and every software development company must fulfill these business functions to some degree. Within each business function, there are 3 security practices, and each of these security practices can be improved independently. Also, the method of improvement is to cover the so-called maturity levels within each practice, which are 3 as well. From the DevSecOps approach and the Open SAM framework, you can have all the different phases. As you can see here, they are almost the same. The only thing that is missing in the DevSecOps model, but is implied by the everyone is responsible for security term, is the governance function, and more importantly, education. And why the education practice is that important? So if everyone is responsible for security, this means that everyone should know about security. And it has been reported in many researches, including Gartner's, that developers doesn't know a lot about security, or if they know something, it is very little. And I'm sure that most of you have attended security awareness trainings, and their most common feature is that they're quite general and they're not teaching skills. Here we cannot really continue with the DevSecOps perspective. We cannot even start it if we haven't educated well enough the development and operations functions. So from DevSecOps perspective, it is important to have role-specific security trainings, and this must extend to skill trainings. Because why developers will be trained in security? Because vulnerabilities are reported on coding mistakes in the end. And the developer must write secure code and apply proper mitigation for security vulnerability, but how he will do it if he can exploit it? What we have done in this area in Experian is that we have defined all the roles in our organization in development and operations, and we have applied role-based trainings. On top of that, we have defined a security role, which is part of every product. So everyone who was part of this security group is called Virtual Security Champions Group, had to apply all the trainings for themselves, for the operations, for development teams, for all the roles we have identified in the beginning. And afterward, we had also security testing, security trainings for which were part of the security functions itself. So in the end, what we have is some people that are part of the product development. They can work in every part of the software development lifecycle, and they can provide all the consultation and insights on the construction and verification functions, which are here. DevSecOps also implies that automation should be adopted. Here we certainly cannot automate security requirements or secure architecture, but we can add automation to the security testing part of the verification function. Environment hardening practices and in the operations part, as well as issue management and operational enablement, all these functions can be automated on their own, but this is a very big topic, so we are going to continue with the security testing. How we can make the security testing practice efficient and what could be automated there? First of all, there are several types of security testing applied to software development. These are static, dynamic, and manual application security testing practices, and also third-party library vulnerability management. Also, security testing can have different scope from different perspectives. If you're looking from software development perspective or the dev part of the DevSecOps approach, you will have the scope defined by the application you're deploying. But when this application goes to production, then dynamic testing or the other parts of the security testing are going to be focused on the whole vulnerability stack, including operating system, application server, and so on. For security testing to be efficient, it is very important to have the proper tool set. That will depend on the technologies you have adopted in your company, but integrations of security tools with common development tools is a must. Another important point related to security testing activities is a good process definition. Adopting a clearly defined and common process when dealing with vulnerabilities removes a lot of the uncertainty of what is the expected workflow in different situations from the development team. This workflow, in fact, might look very different from what you have seen in standard bug workflow, but if it is part of the official bug tracking system, it will speak the language of development, which is beneficial in the end. Here is one very good quote from an application security article. Anecdotally, it is believed that SAST only covers up to 10 to 20% of the code base, and thus another 10 to 20%, where SAST is the acronym for static analysis and thus for dynamic analysis. Okay, then what happens with the other 60 to 80%, and how they can be covered, or can we just extend these 10 to 20% so that we have all the code covered by security testing? Let's go briefly to the different types of security testing. First of all, the static analysis. It is performed on non-runtime environment. It is performed on binary or source code, depending on the vendor you have chosen. And static scans are searching for coding patterns used in the program code to determine vulnerabilities. Also, static analysis to be effective, it should be executed regularly as part of the software development process. Some common issues with static analysis tools are the high rate of reported false positives and the scan duration, which can sometimes be from several hours to several days. Some of the SAST vendors are Veracode, Checkmarks, and IBM. From DevSecOps perspective, both the scan duration and the big part of false positives must be addressed. So how can we do this? First of all, the SaaS vendors on their own have identified this problem, and now they are providing the so-called fast scans or integration with development environments. This type of IDE integration catches common security mistakes and offers pointers to the problem and to their solution. Keep in mind that IDE-based integrations often need to sacrifice breadth so that they're reporting less false positives. And in the end, when you have the whole application scanned by the static analysis tool, and not only the parts that you have been working on in your development environment, in the end, you will have more issues reported afterwards. The benefit of these scans are that they are fast. Developers get the security feedback immediately before even the code commit. And remediation process is done during feature implementation. This addresses security technical debt early in the SDLC, and additionally, you can extend on top of it automatic scanning in the build process, automate reporting in the custom in your bug tracking system. In fact, this reporting part is very important because in the end, if you have all the security issues integrated with your Jira, you can see and not only you, but your project managers can see what is the level of the release and whether you will need to have to plan something in addition. Other things that you can use here is how static analysis is integrated in one IDE. Other things that you can do are with the next type of yes, it's static scanning again, but on third-party components or third-party vulnerability management. Using components with known vulnerabilities, which defines third-party libraries used in your code, can pose a huge risk to your application, and it is part of the OWASP top 10. This list represents a broad consensus about the most critical security risks to web applications. According to the SNCC security company, the root cause for data breaches came from OWASP top 10 entries, when the root cause was anything from the OWASP top 10 list, is greater in this topic, third-party libraries, and this has caused 12 of the top 50 breaches for 2016. This statistic covers only, This statistic covers only the information when we had also the root cause part of these reports that SNCC looked into. Also, according to Black Duck report for 2017, third-party library components which are used in commercial software are at the rate of 96%. So you can be sure that everyone here in the room is using third-party library components in their software. From these third parties adopted, you have 147 different open source components for application, which is a very big number. So how we are doing third-party library vulnerability management? Until very recently, this was a manual process, and we had to go, for example, to external vulnerability databases, some were public, others proprietary, and look for vulnerabilities for each of the libraries. So when you have the manual process approach, you have also false positives, or you can just not oversee something. In the last years, there are some tools which have emerged, and they are doing pretty good job in identifying third-party libraries and the risk associated with them. One source for gathering vulnerability information on third-party components is the National Vulnerability Database, or NVD. You can do searches in NVD. I have done here a search for average distribution over time over the severity. And you can see that, for example, for the last year, this database exploded with more than twice than the previous year. We had 14,000 vulnerabilities on third-party components reported for 2017, and more than 4,000 of them were high. The root cause for this number, in fact, because you can see that the trend is the same for the first half of this year, is that there was focus on researches that were made on third-party library vulnerabilities, and also the software which is covered by the MVD and other databases have become a lot. So this is likely why this happens. I have extracted from MVD the latest vulnerabilities reported for the Jackson library, which is a widely used JSON parser for Java. And when you look to the security score, which is critical, for example, for 3 of the 4 issues here, in the description it is written, allows unauthenticated remote code execution. This basically means full compromise of a remote system. And moreover, an attacker may use such compromised system as a launching point for further attacks inside the data center. So if you have this library used in your software, it is better to patch immediately. The root cause for this is, again, because for 30% of the vulnerabilities reported here, you have, for the last year, public exploits. And the public exploit for a vulnerability means that everyone tries to try this exploit immediately after the exploit is announced. So the risk is very high. So how to make the third-party library vulnerability management process better and faster? First of all, it is very important to define a workflow for adopting and maintaining third-party software. Who will approve this third-party software? Who will check for the risk associated? Risks are different. Some may be, for example, that this open source library doesn't have a release in the last 2 years, and it had a reported vulnerability in the latest release. So after this step is completed, the most efficient approach to adopt the vulnerability management process is to add a tool which will search for proven vulnerabilities in security databases and will monitor on the legal risk of using third-party libraries. Because sometimes we have restricted licensing, and if the license is not checked, it can have consequences, legal consequences for our company. Vendors that are providing such tools are Black Duck, and from the open source components, you have OAuth dependency check, retard.js for JavaScript libraries, and others. This process also, after you have adopted the tool, should be executed regularly as part of the active development and periodically after release to ensure that you are still good to release. And you have to patch some vulnerabilities if they're reported fast, or supply proper mitigations at the network level. Also, these tools can be automated to scan, and the scan can be triggered as part of the build process, and reporting again can be done in Jira. Dynamic scans are performed on pre-configured environment, which means the program is in operation. Thus, tools monitor system memory, functional behavior, response time, and others to identify potential vulnerabilities, including in third-party interfaces. Dynamic scans are performed usually from the login screen of the deployed web application, trying to get as much of the functionality executed as possible following web links. Dynamic scans reports find practical but limited exploit paths, and they have different scope during development and operations, as we already talked about. During development, the scope is on the application developed, and during operations on the whole vulnerability stack. Sometimes you will need even different tools to perform it, depending on the vendor. Some Dust vendors are Rapid7, Qualys, Veracode, and Checkmarks. To enhance the traditional dynamic analysis tool, you should again automate the scanning, the build process. You should automate reporting as part of the ticketing of the bug tracking system. But in addition to that, you can define gaps using additional analysis and manual testing results. You can utilize automation frameworks and tools adopted by the quality engineers, and you can enhance the dynamic scanner with customizations and extensions of the scanner capabilities. If you were looking to all the 3 types of scans that I have talked about, you maybe understand that dynamic scans are the thing we will want to enhance for the DevSecOps approach, although the other tools have their roles as well. The problem with the current dynamic scans is they're a bit dummy, and this is very visible when you are adding for dynamic scan a more complex application. Usually, dynamic scanning tools cannot go very further in these applications because, for example, your software relies on certain data to be provided so that certain screens can be executed, and the URLs, of course, can be part of that. It is very interesting to see the result of one of the test vulnerable web applications after a dynamic scan is executed. I have added here the challenges solved by one of the dynamic scanner solutions I have evaluated on the vulnerable OWASP Juice Shop application, which is written in Node, JS Express, and Angular. And this type of applications can be very useful if you're doing some workshops for training programs. The bottom line to enhancing the dynamic tools is that you should extend, you should not use them in the traditional ways, but you should get all the APIs and all the execution paths that the vendor can provide to enhance your evaluation results. We'll be going back in the dynamic analysis part and enhancing it in the next part of the presentation, because I want to show how this looks in practice. And the last type of test is the manual testing or penetration testing. And as with the dynamic testing, penetration test is performed on a live environment, and also it is performed on anonymized or fake data. Penetration test is a human-guided process of attack on a system, also known as ethical hacking. And during the pen test, a variety of tools are used to inspect the program behavior to identify vulnerabilities. For manual testing, pen test is very efficient, and you have very rarely false positives. But on the other hand, it is also costly and time-consuming. In fact, the only difference between pen tester and a hacker is the approval of security testing activity. And bottom line here is that you don't have to try to penetrate your corporate network system or your corporate applications without you have a formal approval. Pen testing is an industry. You have a whole Linux distribution full with pen testing tools. It is called Kali Linux. And some of the other tools which are used especially for web application security testing is Burp Suite Prom. All the Kali Linux for web application testing can also be used here. And we are here back to the use case. To recap, we have 2 project managers receiving 2 manual security test reports. These tests were executed by the same security testing vendor. They were executed also against the same core software, but for different deployments. The configuration of the software is following similar patterns, and the security reports show different vulnerabilities in the end. And which report here is the right one? Can such issues be resolved before release? So it should be clear by now that both the reports were accurate, and what can be done afterwards is what is interesting in fact here. So what we have done in this case, we have conducted a time-box internal pen test of the core software, for which execution we have collaborated with business analysts and quality assurance engineers on the pen testing exercise to execute as much business functionality as possible. We have also integrated additional tools to detect the actual code coverage at runtime to achieve maximum functionality coverage with the running proxy. And in the end, having 50% coverage from the tool we found 2 unreported vulnerability categories, and also more vulnerabilities were found in the already reported categories. How we can use these results? It is pointless in quality environment to have pen testing executed every several weeks because we will have, in the best case, new functionality every several weeks, and we will want to be deployed. We can still use these penetration testing results, and we can extend our dynamic scanner to include some additional capabilities. Also, we will add the dynamic scanner to the application release pipeline, and we will try to use the enhancements of the dust tool to receive better results. So let's say we have used the results gathered by the previous use case. How will they look like in practice? Here I have used the vulnerable OWASP web GOAT application, and the results are gathered by an unguided dynamic scan. This means I have added only URL to the application and user credentials to the login screen. And the scanner has found the listed vulnerabilities. These are 8 types of vulnerabilities reported. Then we are adding a tool for code coverage, as we have done in the previous use case. It is applied, OWASP code pools is applied at runtime, and we are trying to extend the link scanned. Previously, we have attached an intercepting proxy, so the traffic is going through it. Depending on the technology stack, you might have better options to use some additional tool like the code pools, but here this was sufficient. And after we are happy with the functionality we have covered, we can restart the scan with the additional data which was gathered here. So here is what is the result after the guided scan was performed. We have reported 20 types of issues, which is more than double the issues types found during the non-guided scan. And this shows the importance of supplying additional data to the dynamic scanner and the way, in this case, we have a very valuable approach. This is not the only way we have extend dynamic scanner. There are certain APIs which can give you the possibility to add custom scanner checks so that the dynamic scanning tool can can search for additional vulnerabilities than what it is, what are the built-in ones. And also you can add additional extensions and customizations. To do some additional pen testing activities or try to automate some of them. One such case will be if you want to do API testing and you want to apply fuzzing on the parameters of the API. This is a very, very beneficial approach, in fact. And as with the Shop application here, if we go back to the WebGoat application, we will see how, as the vulnerabilities were found by the scanner, the hacking challenges were resolved. As a next step, this manual process, in fact, can be automated and become part of the QA framework, although in reality, it will be the other way around. You will have the QA automation, and you will use it to be executed as part of this guided scanning activity. What we will do next is to add this test to the build pipeline. One way to use dynamic is to use the dynamic tool vendors APIs to trigger the scan and execute it in the stack of non-functional tests. And you can utilize existing QA frameworks as it is shown here. In fact, the same way you can define use cases and misuse cases to validate security controls and also to include additional security testing tools. This is how the test report will look like in Jenkins, just as with any other of the executed tests. And you can fail the build if certain conditions are met on the received results from dynamic scan. For example, here I will fail the build if high or medium severity vulnerabilities are found, and I will stop the release process. Another way to trigger the dynamic scan from the build pipeline is to use Jenkins plugin from the vendor and apply it as a post-build action in your Jenkins job. This is an approach which is used and applicable for most of the vendors I already talked about. Keep in mind that when you receive the results, they will be in XML or JSON format, so you might have to do some additional processing. By the way, this type of adding to builds can be used also to the SAST scans and to the third-party library vulnerability scans, because in the end you have a set of non-functional tests, and based on the results on the non-functional tests, you can grant permission for a release on, you can cancel a release, and this can be done according to your company's policy. So this is a very automated approach. I will not show you how Jira is integrated, but this is pretty straightforward as well. You can have Jenkins plugin, you can have Jira plugin, or you can just use APIs and use Jira with API approach. So as part of the, what we have achieved here, as part of the initial pen test, we have provided metrics and test cases which could be automated. We have also verified the extended case using a code coverage tool. We have adopted the current build infrastructure and the QA framework. The only requirement is that you need to be able to use the dynamic scanner proxy. And adding automation, we can now feed the dynamic scanner to perform guided, authenticated crawl and scan. What was the purpose of this use case? In DevSecOps release cycle, you cannot have a pen test executed for each release, but adding this approach and applying it to both static, dynamic analysis and third-party library vulnerability management tools, you can have a very good view on whether a release can be security sign-off or not. So in summary, what are some of the steps that will allow you to speed up the release process without sacrificing security and implementing the DevSecOps approach, which means automation in the end? You have the security training, first of all, which is role-based, and some security champions developed. You have these people are working with business analysts and developers throughout the software development lifecycle. Then you have defined process for vulnerability management, which is common for static, dynamic, and third-party library vulnerability management tools. If you haven't adopted these tools, you should do it. And after this, we are starting to use all the features that the providers are giving us in these tools to extend on them and use them as automated in the build and the bug tracking systems. In the end, you can use cyclic pen test results to extend the dynamic scanner capabilities as well. This, in fact, concludes what I wanted to share with you, and we have some time for questions. Any questions?
Thank you. About the vulnerabilities per year, 2017, if I'm not wrong, was quite a boost. Does that mean that there are many more issues, or the software tools for detecting them become much better? And what does it mean that 2018 is even better than 2016?
Well, so the common, what has happened in 2017 is there was a lot of software produced for the IoT. And these are a lot of open source components as well. And also there was a focus of researches on open source component to try to find vulnerabilities. So there is a focus first from researchers' side, and then we have a lot of other applications that were that started to be part of this database. That's why you have this trend. And this trend has not slowed down. So basically, we will have something similar for this year as well.
Thank you.
Any other questions? Okay.